Hello everyone, Mr. Fawcett here, and we are back with another AP Calculus lesson. This is going to be part 2 of the lesson on particle motion. It should be a fairly quick part. We just have one problem to do and then a couple of questions to think about. Although maybe we'll spend more time thinking about those questions than I anticipated. We're going to start off on this page though. We have a little graph here, and it is the position function S of t. It says it's the position function of a particle that's moving along the x-axis. So all the particle is doing is moving left or right. We have to be careful. This function is not giving us the path of the particle, right? So the particle is not moving up and then down and then back up again. These y values right here are telling us how far the particle is along the x-axis. So let's say this y value is 4. That would mean, again, the particle is just moving left and right. That would mean that a particle is at the position of x equals 4 at that moment in time, right? So this x-axis is t values. So at, let's say, 3 seconds, the particle is at 4 units on the x-axis. So just to make sure we have a clarification, the particle is not moving up and down and left and right, it's strictly moving left and right. All right, let's take a look at our first question. It says, at what points is the velocity equal to 0? Justify your answer. Well, velocity is the derivative of position, and we're given the position function. So we would just think about a regular function and where the derivative is going to be equal to 0. Well, we're going to look at our minimums and our maximums, right? These are the points right here where the tangent line would be have a slope of 0. So we can say at B and D, because these are, we can say, relative maximums and minimums. Relative maxes or mins of S of t. All right, on to number 2. It says, on what intervals is the particle's velocity positive? Justify your answer. Well, where is the derivative going to be positive? We need to think about where the original function is increasing. So these intervals here, we are going to have from f, oops, it's my eraser, from f to b, so the interval f comma b, and we also have from d to e, so union the interval d to e, because S of t is increasing on these intervals. And we could actually just say v of t greater than 0 on those intervals. For number 3, it's just the opposite. On what intervals is a particle's velocity negative? So we are looking for intervals where the original function is decreasing, and that is only from b to d. So v of t is less than 0 on the interval b, d, because S of t is decreasing on these intervals. Okay, let's take a look at question 4, if there is one. Let me clear this. There is not. So that was just those 3, fairly straightforward for that graph. Now we're going to look at a few more questions, a few more relationships, and then we're going to call it a video. So it says, assume a particle is moving along the x-axis, and then we're going to fill in the second half of each statement. If the velocity is positive, then the particle is moving, well, if it's moving left and right, and the velocity is positive, then the particle is moving to the right. And again, I would encourage you to try to fill these in before you listen to the solutions. If the velocity is negative, then the particle is moving. Well, it's going to be moving in the negative direction, which is to the left. And here's where we come to something that we haven't really talked about before, at least I don't think, but you may have seen it as a physics class. So this is talking about speed. So we have to figure out, when is a particle going to be speeding up based on its velocity and acceleration? And I think the easiest way to think about this is when you're in a car. All right, so when you're in a car and you're going forwards, right? So let's say you're, driving down a road, you're going 45 miles an hour, but you realize you're going to be late, right? So you hit the accelerator and that increases your velocity, right? Your velocity keeps growing. Well, your velocity is positive because you're going forwards. Your acceleration is also positive because you hit the accelerator, which means you're going to be speeding up. So when your velocity and acceleration have the same sign, your speed is increasing. This works the same way if your velocity is negative, right? If you put your car in reverse and you step on the gas, right? And let's say you're going negative 15 miles per hour, you're backing out of your driveway. If you hit the accelerator, your velocity is going to be getting more negative, right? When you hit the accelerator and your car is in reverse, your car speeds up, but you're going backwards, right? Because your velocity is negative, your acceleration is also negative, so you still end up speeding up, even though you're going in the backwards direction. So if your velocity and acceleration have the same sign, your speed is going to be increasing. Now, when your velocity and acceleration have different signs, let's say that you're still going forwards, you're going 45 miles an hour, but you see a cop on the side of the road, and it's like almost instinctively we hit the brakes, regardless of whether we're going the speed limit, we're going under, or we're going over. We just automatically seem to hit the brakes. When you hit the brakes, right, that's deaccelerating. So your acceleration actually becomes negative because you take that velocity, let's say you're going 45 miles an hour, you hit the brakes and your velocity starts to decrease. Well, that's due to the negative acceleration, which means that you're slowing down. Your speed is decreasing. So when your velocity and acceleration have different signs, the speed of the particle or of you or whatever is the object that's moving is going to be decreasing. You may want to pause the video and think about this analogy a little bit more, just because you will have to remember it for certain questions, right? They're going to have questions where they say, is the speed of the particle increasing or decreasing at t equals 9? And you're going to have to remember that speed and velocity are not the same thing. So you can't just find the velocity, right? Because speeding up and slowing down depends on, well, is the acceleration positive or is it negative compared to the velocity being positive or negative? So you have to find both signs of the velocity and acceleration and compare them. If they're the same sign, if they're both positive or both negative, the object's speeding up. If one is positive and the other is negative, then the object is slowing down. All right, let's go ahead and answer our last 3 questions for this video. Number 5, what is happening to the particle when the velocity changes signs? Well, let's think about it. If my velocity goes from positive to negative, we already said the particle is moving along the x-axis, so if the velocity is positive, it's moving to the right. If the velocity changes to negative, it means the particle then starts moving to the left. So it's moving to the right, and then it starts moving to the left. If it has a negative velocity and then changes to positive, well, that just means it's moving to the left and then immediately changes to moving to the right. Either way, the particle is changing directions. The particle is changing directions. All right, number 6. If the velocity is 0 but the acceleration is not 0, what is the particle doing? Well, this one we have to try to visualize. I'm going to try to give you a visual through the video, but you may have to you may have to think about it a little bit. Let's say a particle is moving to the right, right? So it has a positive velocity, but the acceleration is negative. Well, as we move to the right, if our acceleration is negative, that means we're going to be gradually slowing down. Eventually, we're going to slow all the way down to 0 if the acceleration is negative, right? If you're going 45 miles per hour and your acceleration is negative 9 miles per hour, well, after 5 hours, right, you're going to be at a velocity of 0, right? You're going to be stopped. But the thing is, if your acceleration stays negative, you're actually going to immediately go in the other direction, right? Because let's think about the car example again. If you're going 45 miles per hour, but your acceleration is negative 9 miles per hour, well, that means after 5 hours, you'll have a velocity of 0. But if your acceleration stays negative 9 miles per hour, that means you'll start moving backwards. And after 1 hour, your new velocity will be negative 9 miles per hour. After 2 hours, it'll be negative 18 miles per hour. So if your acceleration is negative and your velocity is positive, eventually the acceleration is going to force you to stop and then go in the other direction. So when the velocity is 0, but the acceleration is not 0, the particle is not stopped. It's momentarily changing its direction. So it's either changing from going from in the positive direction to the negative direction, or it's changing going from the negative direction to the positive direction. So we can just say momentarily stopped, just for an instant. As it changes direction. So it's not just sitting there when that happens, right? And you can think about the car example. As soon as your velocity in the car reaches 0, if your acceleration is still negative, you're going to immediately start going backwards. This is different from when the velocity is 0 and the acceleration is 0. When the velocity is 0 and the acceleration is 0, well, it means you're just sitting there. So we can say the particle is stationary. And again, that's because if your velocity is 0 and your acceleration is 0, well, your acceleration is not changing your velocity to the positive or negative, right? Acceleration is what changes your velocity. And if you're at 0 and the acceleration is at 0, your velocity is constant. It's not changing from 0. Okay. I know this was a lot of relationships over the course of 2 videos. That being said, particle motion problems are a big part of calculus, so we have to know the relationships between position, velocity, and acceleration. There are some problems for you to practice. We'll do some more practice in class as well, but this is where we're going to stop part 2. So as always, enjoy the rest of your day, and I look forward to seeing you for our next lesson.